Hello, my name is Selva Ganesh, and together with Akil and Gerald, today we'll be presenting our assignment video, and that is to create logic gates using a multiplexer, which specifically is the 74LS151. And we need to design and simulate the system that contains high signals and don't care signals. So we are now going to explain further about this multiplexer. I will pass down to my groupmate on explaining the truth table and the software.
I'm Jared from and I'll be showing how we get the multiplexer diagram with the Boolean function given. We first plot the 4-bit truth table. The output 1 is 0, 2, 6, 9, 10, 11, 12, 15. The don't care is 313, while the others is 0. This is the selection table. ABC is related to the input. To find the input, we use the implementation table. And then we circle the decimal, which has the output of 1. And then we analyze each row. For the output function, we can refer back to the selection table. So looking at here, A prime, B prime, C prime at I0, which is the first row. A prime, B prime, C, I1 is the second row, and so on. And then we sub in the input, like this. And then we can construct the multiplexer diagram. For the logic 1, it is connected to I1, I5, and I6. The ground is connected to I2, the D is I4, and I7. To get the D prime, we just put the inverter for D, and then D prime is I0 and I3.
Hello, my name is Muhammad Afisha and I'm going to construct the circuit. I'm using circuit bus here because it's open source and free to use for everyone. Okay, let's get started. First thing first, you have to prepare every component you have for the unit for the circuit. This is the pin input. Just take it from the input here, and don't forget to label it as D. This is a constant input. You take it from here and label it as PCC, but don't forget to change the value into 1 since originally it starts from 0. This is your ground, this is your pin input, but you have to change the setting by change the bit width from 1 to 3. Okay, this is the NOT gate. Just take it from the gate here, you see. And then your multiplexer, you can take it from the decoder and mux and just place it anywhere you want. Okay, since our task where we have to use 3-bit multiplexer in our circuit, so we change the control signal size from 1 to 3. And this is our output. Okay, next part is for the connection. All you have to do is just press the green point here and connect best from the circuit you have. This is for the input and this is for the output.
Hello again, back to my part. So now I'll be verifying the circuit that my colleagues have already done and also verify the truth table whether it is correct or not. So I have now loaded up the circuit right here on my right, and on my left is my table that I'll be filling in. So what I'm about to do right now is I'm going to fill in the inputs A, B, C, D, and whatever output that produces on this blue box right here, I'll write down on the table. I now have all the outputs from the circuit, so let's compare it now to the truth table that my friend did earlier. So as you can see, the outputs are pretty much the same with one another. The reason why here X is 1 over here is because it's, as we all know, it's don't care. It's either 1 or 0, so it is also right. And yeah, pretty much everything else is correct. So that is all from our group. Thank you very much for watching.